And now we're gonna talk about meshes. The section contains information on working with meshes and Unity, and this is inside of graphics, so you can go here into the graphics and check out more information. But here they give us a wireframe view of the meshes and Unity's 2020.1, and here we have the HDRP template example project, and HDRP stands for High Definition Render Pipeline. It's a high fidelity scriptable render pipeline built by Unity to target modern computer shader compatible platforms. So we have that, and pretty much here we're gonna have the meshes introduction, the mesh data, mesh assets, mesh components using meshes with C# script, level of detail, so LOD stands for level of details for meshes. We have compressing mesh data, loading texture in mesh data, and right now let's move here. Let's go into the meshes introduction. So let me open here one of my projects, so the wheel collider or whatever project you have, and you can just click new project and then just start from a 3D project here, just 3D, and then create a project. So I'm gonna close it since I already opened this one, and we can just leave it like that for now. Okay, so here a mesh is a collection of data that describes a shape. In Unity you see meshes in the following ways. In graphics you use meshes together with materials. Meshes describe the shape of an object that the GPU renders, and materials describe the appearance of its surface. In physics you can use a mesh to determine the shape of a collider, the formable meshes. In addition to regular meshes, Unity also supports the formable meshes. The formable meshes fall into the following categories. So we have the scheme meshes, we have the meshes with blend shapes, and the mesh that work with a cloth component for realistic fabric simulation. So let's talk about a little bit of the scheme meshes. These meshes work with additional data called bones. Bones form a structure called a skeleton, also called a rig or a joint hierarchy, and the scheme mesh contains data that allows it to deform in a realistic way when the skeleton moves. You usually use scheme meshes for skeletal animation, and these are all these links if you want to check it out. Well, they're sending us to Wikipedia with Unity's animation features, but you can also use them with rigid body components to create a ragdoll effect. Okay, meshes with blend shapes. These meshes contain data called blend shapes. Blend shapes describe versions of the mesh that are deformed into different shapes, which Unity interpolates between. You use blend shapes for morph target animation. So this is the link, morph target animation, and this is pretty much information from Wikipedia, so you might want to verify with another source, which is a common technique for facial animation. Okay, so creating meshes. You can add meshes to a Unity project in the following way. So create a mesh as a part of a model in a 3D modeling program, then import it. Unity creates a mesh asset as a part of a model hierarchy. When you import a model, for more information you can see importing models. Create a mesh directly with in editor tools. Unity has built-in primitive shapes such as spheres and capsules that you can place directly into a scene. You can also use a package like ProBuilder to model a custom mesh in the editor, and we already see they create meshes with code. Now, working with meshes. Unity stores meshes in your project as mesh assets, and if we go here you're gonna see that, well, I don't have it, so I have the assets folder, inside I have the scenes folder, and we can just pretty much add here another folder and just name it meshes, and from there we can just pretty much start creating. Let me see if we have something similar here. Mesh render, no, we don't have it right here. Okay, so let me see. Unity stores meshes in your project as the meshed assets and representing in C# code with the mesh class. Okay, depending on how you use meshes, they work with different components. In graphics, Unity renders regular meshes with the mesh render components and the formal meshes with the skin mesh render components. In physics, Unity uses the mesh collider component to determine the shape of a collider. And we have that. For more detailed information about the data that a mesh contains on how Unity represents the data, see the mesh data. So let's move to the next one. Mesh data. This page contains information on the data that a mesh contains and how Unity stores that data in the mesh class. So the overview. A mesh is defined by these properties, so vertices, topology, indices. So let's check out, and you can pretty much click here and you're gonna have a more detail. Let me see, vertices. No, yeah, that's all the information that we have. But vertices, so a collection of positions in 3D space with optional additional attributes. Topology, the type of structure that defines each face of the surface. We have indices, a collection of integers that describe how the vertices combine to create the surface based on the topology. In addition to this, deformable messages contain either blend shapes and bind poses. So blend shapes, data that describe different deformed versions of the mesh for use with animation. Then we have bind poses, data that describes the base pose of the skeleton in a skin mesh. We have the vertex data. The elements of the vertex data are called vertex attributes. Every vertex can have the following attributes: position, normal, tangent, color, up to 8 texture coordinates, bone, weights, and blend indices, skin meshes only. Okay, so we have some geometry here or something similar. Internally, all vertex data is stored in separate arrays of the same size. If your mesh contains an array with 10 vertex positions, it also has arrays with 10 elements for each other vertex attribute that it uses. In C#, Unity describes the available vertex attributes with the vertex attribute enum. You can check whether an instance of the mesh class has a given vertex attribute with the mesh that has vertex attribute function. We have the position. The vertex position represents the position of the vertex in object space. Unity uses this value to determine the surface of the mesh. This vertex attribute is required for all meshes. In the mesh class, the simplest way to access this data is with the mesh that get vertices and the mesh that set vertices. Unity also stores this data in mesh that vertices, but this older property is less efficient and user friendly. Okay, so we have the normal. The vertex normal represents the direction that points directly out from the surface at the position of the vertex. Unity uses this value to calculate the way that light reflects off the surface of a mesh. This vertex attribute is optional. In the mesh class, the simplest way to access this data is with the mesh that get normals and the mesh that set normals. Unity also stores this data in mesh that normals, but this older property is less efficient and user friendly. We have the tangent. The vertex tangent represents the direction that points along the U horizontal texture axis of the surface at the position of the vertex. Unity stores the vertex tangent with an additional piece of data in a 4-component vector. The x, y, z components of the vector describe the tangent, and the w component of the vector describes its orientation. Unity uses the w value to compute the binormal, which is the cross product of the tangent and the normal. Unity uses the tangent and binormal values in normal mapping. This vertex attribute is optional. In the mesh class, the simplest way to access this data is with the mesh that get tangents and the mesh that set tangents. Unity also stores this data in mesh that tangents, but this older property is less efficient and user friendly. Then we have the UVs, that is the texture coordinates. Let's just read a little bit only. A mesh can contain up to 8 sets of texture coordinates. Texture coordinates are commonly called UVs, and the sets are called channels. Unity uses texture coordinates when it wraps a texture around the mesh. The UVs indicate which part of the texture aligns with the mesh surface at the vertex position. UV channels are commonly called UV0 for the first channel, and then UV1 for the second channel, and so on up to the UV7. The channels respectively map to the shader semantics. So here we have the text coord 0, text coord 1, and so on up to the text coord 7. Now let's check out color. The vertex color represents the base color of the vertex. If any, this color exists independently of any texture that the mesh may use. Okay, so in the mesh class, the simplest way to access this data is with the mesh.getColors and the mesh.setColors unit. Unity also stores this data in mesh.colors, but the solver property is less efficient and user-friendly. Finally, we have the blend indices and bond weights, and a skin mesh blend indices indicate which bonds affects a vertex, and bond weight describes how much influence those bonds have on the vertex. In Unity, these vertex attributes are stored together. Okay, we have topology. Topology describes the type of face that a mesh has. So a mesh topology defines the structure of the index buffer, which in turn describes how the vertex position combine into faces. Each type of topology uses a different number of elements in the index array to define a single face. Unity supports the following mesh topologies: so triangle, quad lines, line stripe, points. And if we go here, we go into game object and 3D effects. We are gonna see the quad, the plane. What else? We have the ragdoll. Okay, so here they give us a point. The points topology doesn't create faces. The points topology doesn't create faces. Instead, Unity renders a single point at each position. All other mesh topologies use more than one index to create either faces or edges. Okay, index data. The index array contains integers that refer to the elements in the vertex position array. These integers are called indices. Unity uses these indices to connect the vertex position into faces. The number of indices that make up each face depends on the topology of the mesh. And in the mesh class, you can get this data with the mesh.getIndices and set it with the mesh.setIndices. Unity also stores this data in the mesh.triangles. But okay, for example, for a mesh that has an index array containing the following 0, 1, 2, 3, 4, 5, if the mesh has a triangular topology, then the first 3 elements, so 0 counts as an element. So we have 0 element, 1 element, and the 2 elements, so the first, the second, and the third. Identify one triangle in the following 3 elements, so 3, 4, and 5. Identify another triangle. There is no limit to the number of faces that a vertex can contribute. Okay, and we have the winding order. As you can see here, we have the order of the vertices in each group, and the index array is called a winding order. Unity uses winding order to determine whether a face is front facing or back facing, and in turn whether it should render a face or call it excluded from rendering. By default, Unity renders front facing polygons and calls back facing polygons. Unity uses clockwise winding order, which means that Unity considers any face where the indices connect in a clockwise direction as a front facing. So here Unity's winding order visualized as a prism. So here we have pretty much we are following kind of like the clockwise, and here we are following anti-clockwise, we can say. So 1, 2, 3, that would be one triangle. Then we have the 4, 5, 6. This is pretty much against clockwise. Okay, the above diagram demonstrates how Unity uses winding order. The order of the vertices in each face determines the direction of the normal for that face, and Unity compares this to the forward direction of the current camera perspective. If the normal points away from the current camera's forward direction, it is back facing. The closer triangle is order 1, 2, 3. So this one 1, 2, 3. This is clockwise, which is a clockwise direction in relation to the current perspective. So the triangle is front facing, so this triangle is front facing. The further triangle is order 4, 5, 6, which from this perspective is an anti-clockwise direction, so the triangle is back facing. So that is that. And finally, we have the blend shapes and the bind poses. So let's check out real quick the blend shapes. Blend shapes describe versions of the mesh that are deformed into different shapes. Unity interpolates between these shapes. You use blend shapes for more target animation, and again, we already saw that. They're gonna send us to Wikipedia, but yeah, I mean that's pretty cool. Some images. So you have this and this example from the open source project Sintel, so you can check out that. Let me see, which is a common technique for facial animation. Let me see. Yeah, I remember some of that in kind of like a mathematics, kind of like a linear algebra. Blend shape data is stored as blend shape vertices. Blend shape data is sparse. This means that there isn't a blend shape vertex for every mesh vertex. There is only a corresponding blend shape vertex if the mesh vertex deforms. A blend shape vertex contains deltas for position, normal, and tangent, and an index value. The meaning of the index value depends on how you request the data. In the mesh class, you can access blend shape vertex data with the mesh that get blend shape buffer. So we have that, the mesh that get blend shape buffer. This returns a graphic buffer that provides access to the blend shape vertex data on the GPU. This method allows you to choose between two different buffers, one that orders the data by blend shape and one that orders the data by mesh vertex. The choice of buffer determines the meaning of the index value and the layout of the data in the buffer. More information, so you can check out that, the blend shape buffer layout, and working with blend shapes. And finally, the bind poses. So in a skin mesh, the bind poses of a bone describes its position when the skeleton is in its default position, also called its bind pose or rest pose. In the mesh class, you can get and set this data with the mesh that bind poses. Each element contains data for the bone with the same index. This data is required for the skin meshes. So this is pretty much all that we have for the mesh data.